Hello, bachcho. Let's read the question. So the question says, what is the effect on the interference pattern in Young's double slit experiment due to each of the following operation? So the operation is the whole apparatus is kept in a denser medium. So to understand the question, we must first revise the key concept behind Young's double slit experiment. So the key concept becomes Young's double slit experiment, also said as YDSE. So, what was Young's double slit experiment? It was that when two slits, open slits of very small size, are kept in the path of a plane wavefront, and their image is taken at a screen at some distance. Let's suppose this distance is capital D, and the distance between two slits is small d. So, what do we observe in the screen? We observe a pattern in which and there is a central bright spot at the center of the screen between the two slits, and there are several white spots at equal intervals on both sides of this central white spot. Okay, so these are called fringes. There are dark spots also, they are called black fringes and white fringes. So the distance between two fringes is known as fringe width, also called fringe width, and is denoted by beta. So the next key concept is So the next key concept is the formula for beta. So the formula for beta is given by lambda into capital D by small d. Here lambda is the wavelength of a incoming wavefront. D is the distance between screen and slit plane, and small d is the distance between the two slits. So keeping these two key concepts in mind, and the next key concept is whenever we put uh, an entire apparatus into a denser medium, or we can say whenever light enters a denser medium, its wavelength decreases. Now frequency cannot increase or decrease, so frequency remains constant, the wavelength decreases. So lambda dash can be written as lambda upon mu. So mu is the refractive index of that medium, and lambda was initial wavelength, and thus velocity v also decreases. V dash is equal to v over mu. So these are the three key concepts which we need to remember. So keeping these in mind, let us find the solution for our question. So for solution part, it has asked us that what effect on the interference, what is the effect of interference pattern when whole apparatus is kept in denser medium. So when denser medium is taken into account, then lambda changes to lambda over mu. So this mu is the refractive index of that medium, as we discussed in the key concept. Now the fringe width beta is given by lambda into capital D over small d, and similarly beta dash in the new medium will be given by lambda dash into d over small d, which will nothing be equal to lambda over mu into capital D by small d, because lambda dash is lambda by mu, and it is equal to beta over mu. Hence, beta dash comes out to be equal to beta over mu. So this shows that the fringe width of the pattern decreases whenever we put the apparatus into a denser medium. So this is the final answer, that we observe a change in the fringe width. I hope you understood it well. Thank you.